Hello friends. So today I am going to start with the next topic, that is continuity and differentiability. Okay. So in this topic the first part is continuity and second part is differentiability. So this both the concepts audio learnt it in the previous class, that is first year. Okay. So for continuity we required the limits part which you already learnt in the first year, and for differentiability we required derivative part which is again already learnt in the first year. Okay, so let us talk about first the continuity part. Okay, so for this continuity we required the base of first year limits part. Okay, so in the limits we have seen what is the definition of a limit. I don't want the theoretical definition, so let us have that mechanical definition. The definition is what? Limit x tends to a, f of x is equals to L. Okay, so in this f of x is a function. Okay, this a is a limit point. Okay, or you can say x is approaching towards a, and this L is what? The value of the limit. Again in this you will find two types of limits, that is left hand limit and right hand limit. Okay, so left hand limit is what? Limit x tends to a minus f of x is equals to L, and RHL means right hand limit, that is limit x tends to a plus f of x is equals to L. Okay, so here I have written x tends to a minus, on the head of that a variable I have written the negative sign. Actually that negative sign is for what? It is the notation for LHL, that is left hand limit, and a plus means what? Right hand limit. But when you are substituting the limit as x tends to a minus, so in the place of x we have to put only the a. You should not put that negative sign. That negative sign is for just to give the difference between LHL and RHL. Okay, so this part you have studied in the limit concept. Okay, but somewhat same concept is useful in the continuity also. Okay, so let us talk about the continuity part now. See, in the continuity, so let us take the definition of continuous function first. Yes, now we will see the definition of continuity, or you can say a continuous function. Okay, a real function f, a real function f is said to be continuous, is said to be continuous if first one, f of c exists. Second condition, limit x tends to c, f of x exists. And third condition, limit x tends to c, f of x is equals to f of c. Okay, so to say that the function f is continuous, these three conditions must be satisfied. And see, this real function f is said to be continuous at one point. So that point I have taken as x is equals to c. That point I have taken as what? C here. So therefore, to say that f is continuous, the three conditions must be satisfied. F of c should be exist, limit x tends to c, f of x should be exist, and third condition is limit x tends to c, f of x is equals to f of c. Okay, or simply what you can say, to say that function is continuous, this third condition must be satisfied, because in this third condition first two conditions are already present. So limit x tends to c, f of x is equals to f of c, so this both should be equal. Then we can say that given function is continuous. If suppose this is not equal, then you have to conclude that given function is not continuous. Given function is not continuous. Okay, so this definition you have to use it for normal function. Now normal function means what? For example, if I am having f of x is equals to x square at x is equals to 0, so you have to check the continuity of this function x square at x is equals to 0. Means in the place of c you have to put the point is what? 0. and your f of x is what? X square, and you have to check it. So you should get this, both the parts are equal, then you can say that function is continuous. So this definition you have to use it for normal function. Normal function means what? Like x square or 2x plus 3 or like x cube plus 3x minus 8. For such simple functions we have to use this definition. Okay, now suppose if you have the function of this type, that is, I'll write it here. For example, that is f of x is equals to, okay, f of x is equals to x if x is greater than equals to 0, and f of x is minus x if x is less than 0. So whenever the function is defined in the form of less than and greater than, okay, so whenever the function is defined in the form of less than and greater than, in that case you can't use that first definition. Which one? Limit x tends to c, f of x is equals to f of c. Okay, that definition you can use it only for the simple functions, as I told you earlier. Okay, but if you have the function of this type which is defined in the form of less than and greater than, in that case you have to use the left continuous function and the right continuous function, which is similar as left hand limit and right hand limit. Okay, so that is what? Left continuous function. Definition is what? Limit x tends to c minus f of x is equals to f of c. Okay, and for right continuous function, definition is limit x tends to c plus f of x is equals to f of c. Okay, so these two definitions you have to use it for continuous function which is defined in the form of less than and greater than. See, these two definitions are exactly similar as what? Limit only. That is, this is LHL, this is RHL. Okay, so whenever the function is defined in the form of this type, then you have to find out LHL and RHL. If LHL is equals to RHL, then we can say that given function is continuous. If LHL is not equals to RHL, then we have to say that function is discontinuous. Okay, so these two definitions are for second type, that is, if the function is defined in the form of less than and greater than. Okay, next part. So these are, I have given the mathematical definitions to check the continuity of simple functions or the functions which are defined in the form of less than and greater than. Okay, now the same continuity also we can check it with the help of graphical representation. Okay, and see that graphical representation that will help you at the time of competitive exams. Okay, now see, suppose I'm having this graph now. See, so I have drawn this graph. So how I have drawn this graph? I have started with this point. Okay, and it touches to the origin. Again you will get one more line in the first quadrant. So while drawing this graph, if you observed, I have not lifted the hand. Means there is no breakage anywhere. See here, there is a continuation to draw this graph. So therefore this graph is continuous. This graph is what? Continuous. So this is the graph of which function? F of x is equals to mod x. So this is the graph of mod x function. Therefore this graph is continuous. This graph is continuous. It means what? It means what? That mod x is continuous function. Mod x is continuous function. Okay, now similarly I will take one more now. See, I have taken one more graph here. Okay, so this you can take it as, this graph is f of x is equals to x square. This is the graph of what? X square. Now again, while drawing this graph also, I have not lifted the hand. Therefore again this graph is what? Continuous. Therefore this x square is a continuous function. Okay, let us have one more example now. See here, in the first quadrant I am having this curve, and in the third quadrant I am having one more curve. Okay, so now while taking this two curves now, okay, is there any continuation? No, because in the first quadrant I have drawn one curve, and this third quadrant I have drawn another curve. But after drawing the first curve, I have lifted the hand and then I have drawn the second curve. So there is a breakage in the graph. There is a breakage in the graph. So therefore such type of graph is discontinuous graph. So means with the help of graph also we can decide whether the function is continuous or discontinuous. Okay, so this is the introduction part of the continuity, or you can say the continuous function. So in the next class I'm going to start with the problems. Okay, and the problems are what? We have to check the continuity of the given functions. Okay, so while taking going to see the next video, so please all of you go through this video properly, because I have given the definitions in that, so you note it and buy it, so that will help you to solve the examples very easily. Okay, thank you.